So guys, now we'll be looking at the topic called sorts. Now, certain number can be expressed as ratios of two integers. It can be p over q, maybe, where q is not equals to 0, and these numbers are called rational numbers. And examples of these rational numbers are we have something like 5 over 2, 1 point, it can also be decimal, 3.5, 1.7, and the rest. And also there are also some things that we call irrational numbers. Okay, and this is irrational numbers, and these numbers could be root 2, okay, could be root 5, root 7, and others. Okay, and they are called irrational numbers because their exact values cannot be determined. Okay, and the most common type, the common types that we know is pi, which is also known as 22 over 7, okay, which we approximate as 3.142, also exponential, which is also approximated as 2.7183. Now there's this common saying that pi the 3.142, like the numbers are so large that it represents a cycle of human life. So those are deep things inside pi. Birthday, dates, your day of birth, and other things are also embedded inside pi. If you look closely, the numbers of pi, numbers inside of pi are very numerous, going to infinity. So the rules of surds generally, we have two rules of surds, two basic rules of surds. So we have that okay, root a multiplied by root b is equals to root ab, and root a divided by root b is equals to root a over b. Now notice that we are dealing with multiplication and division, just like we have been doing in indices and logarithm. Now the most important thing that we need to know is that root a plus root b is not the same thing as root a plus b, and neither root a minus root b is not the same thing as root a minus b. Okay, so these are the rules of surd. These two basic rules are the basic fundamentals of surd. If you understand this, you'll be able to caption other things. So let's take a look at examples. So we are given root 9 multiplied by root 16. Okay, now root 9 is 3, and root 16 is 4. So our answer is 12. Okay, and if we follow the laws of indices, we realize that this can also be root 9 multiplied by 16, and 9 multiplied by 16 is 144, and root 144 is 12. So whichever way we do, we will arrive at the same answer. So let's also try root 144 divided by root 9 or root 16. Let's stick with 9. So root 144 is 12, root 9 is 3, so our answer is 4. And if you also go by the law of surds, realize that this is 144 divided by 9, and this will be equal to 16, and this will be answer will be 4. Alright, so understanding this basic law of indices, we can have a very high number, and we'll be asked to simplify further, okay, and to reduce it to a simpler form, and a simpler form can also be called the basic form. So given that we have a number like say let's say root 162. So the best way to do it is to reduce it 162 to common multiples, okay? Common multiples such that we know that 162 is 81 multiplied by 2. So following the rules of sword, we have that this is root 81 multiplied by root 2. Root 81 is 9 multiplied by root 2, and that will give us 9 root 2. Okay, so we can reduce it in terms all to the ends of root 2, root 3, some might have up to root 7. Okay, maybe it's yeah, maybe all these roots that we now have values for. Okay, so let's try another one. We are given root 54. Root 54, and you look at 54. 54 is also 9 multiplied by 6, and okay, and this will give us root 9 multiplied by root 6. Root 9 is 3 multiplied by root 6. That will give us 3 root 6. Now, examples like that, and this process, this 3. Okay, let's take one more example. Let's given as well given root 98. Okay, now this 98 to this basic form can be as root 49 multiplied by 2. Okay, so 49 here, root 49, that's following the rule of sword, multiplied by root 2, and that will give us 7 root 2. Okay, now this form we can now go back. Okay, this is to the reduced form, reduced or basic form, and we can now go backwards. Okay, and we want to take it from their basic form to the complex form. Okay, taking from basic form so complex form, and how can we establish that? So let's take for instance we are given 2 root 3. Okay, we want to take it back to their complex form. So the best thing we can do now is you know that this is 2 multiplied by root 3. Okay, now it's like we're going back in reverse order. We have going back in reverse order. We have that root a. Remember that root a multiplied by root b is equals to root ab. Okay, so going back in reverse order, we know that 2 to get this the square root. This means that what are we going to what's the square root of a number that will give us 2? So definitely the answer is 4. So root 4 multiplied by root 3, because root 4 is the same thing as 2. Okay, and now we apply this law, and we have 4 times 3 all in the square root, and that will give us root 12. Now let's pick another format. We're given 3 root 5, right? So this will give us 3 multiplied by root 5. What is the square root of a number? That will give us 3, and that will give us 9, because root 9 is 3 multiplied by root 5, and in the back we have 9 multiplied by 5, and 9 multiplied by 5 is 45. Okay, and let's take one more. 5 root 3. Now we split them. 5 multiplied by root 3. 5 is a number, and taking it in terms of square roots, that will give us 25, because root 25 is 5 multiplied by root 3. Applying the laws of sorts, so that will give us 25 multiplied by 3, and that will give us root 75. Okay, so there's something called similar sorts. So sorts can be said that they are equal. Okay, but before we go into equality of sort, now let us simply score something the simplification of sort. How can we simplify sorts? We can have a series of sorts. Okay, we can have a series of sorts, and we'll be asked to simplify them. Let's call it simplification of sorts, and we might be asked to just simplify the sorts into a single variable. Let's take for instance we are given root 20 plus root 45 plus root 125 minus 2 root 80. Now we are given something like this. Of course, we can plug this into our calculator and get our final answer. But how do they arrive at the answer? That's the question. Now remember back here that we went from basic form to complex form, and also went from the complex, okay, from the complex to reduce a basic form. So when we are going from the complex to basic form, we can also do the same thing here. Okay, so we reduce it. All these are in complex form and in the complex form, so we reduce them to their basic form. Okay, and with that we can be able to perform the algebraic equations on that or operations on that. So let's take for instance root 20. Root 20 is the same thing as root 4 multiplied by 5, abi, and root 45 is the same thing as saying 9 multiplied by 5. Root 125 is the same thing as saying 25 multiplied by 5 minus 2 root 80. So root 80 is the same thing as saying 8, sorry, 4. Okay, let's take a look at this now. Well, so if we divide 80, well, let's say divide by 5. Okay, so we'll be left with we'll be left with 16. Okay, so that will be 16 multiplied by 5. Okay, so because we are leaving them in all in terms of root 5. So the first thing we need to know is that what will be our common surd amongst all. So sometimes we might notice that most of the time is always in terms of root 5 or always in terms of root 2, and also be the combination of the two. So if we go further, we can now split further and say this is root 4 multiplied by root 5 according to the law of surd, plus root 9 multiplied by root 5, and you can see the good use of brackets here, root 25 multiplied by root 5 and minus 2 into root 16 multiplied by root 5. Now with that we know that root 4 is 2 and this will give us 2 root 5. Root 9 is 3, that will give us 3 root 5. Root 25 is 5, that will give us 5 root 5. Right. And root 16 is 4 and that will give us 4 root 5. Now we can open the bracket with minus 2 over there. That's 2 root 5 plus 3 root 5 plus 5 root 5 minus 8 root 5. Now since root 5 is common, we can take the algebraic sum of everything. So that's 2 plus 3. 2 plus 3, that's 5 plus 5. That is going to give us 10. So we have 10 root 5 minus 8 root 5, and this will give us 2 root 5. Okay, so let's take another example and move on to another subtopic. Let's say 3 root 2, given 3 root 2 minus root 32 plus root 50 plus root 98. Now, the most common question people ask now is how do we know that I'm going to live maybe in terms of root 2 or root 3 or root 5 or root 7? I mean, if you take the multiples of each complex form, then you look at which one is most common among them, then you know the answer to know. So for this now, hmm, for this now, we are given it in terms of root 2, so we might have to stick to root 2. So 3 root 2 minus 32 is 16 multiplied by 2 plus 50. Okay, that's 50 is 25 multiplied by 2, and 98 is 49 multiplied by 2. Okay, so this will give us 3 root 2 minus root 16 multiplied by root 2 in brackets plus root 25 multiplied by root 2. It's 25 multiplied by root 2 plus root 49 multiplied by root 2. So with that, we have 3 root 2 minus root 16 is 4. So this gives us 4 root 2. Root 25 is 5. That will give us 5 root 2. And root 49 is 7. That will give us 7 root 2. So if we definitely perform the algebraic form on everything, yes, so this gives us 3 minus 4 plus 5 plus 7. And altogether we'll have what's 11. 11 root 2. 11 root 2. So before we go further into products we have done, where this all this we've done, simplification of fourth sort stands to gain under we've talked on addition and subtraction of sort. Okay, so from we reduced it down to the from the complex form down um to the reduced form or basic form in terms of root 2 or root 5. It can also be root 3 or root 7 based on wherever we find ourselves in. And then with that, we now be able to perform the simple algebraic form on each and every one of them. So quickly, we want to go into multiplication and division of sorts. But before we go into multiplication and division of sorts, there's something we call conjugate sorts. Conjugate sorts. Now, in conjugate sorts, we'll realize that most of the time sorts are written in terms of roots. Okay, definitely sorts, roots, and straight to the point, we have root A plus root B, and we can also have it to be root 3 plus root 2 plus root 3. And you might be asked, what is the conjugate? Okay, what is the conjugate? Okay, now since they are not rational, I mean sorry, irrational numbers, right? The conjugate of this sort is root A minus root B. Now the thing we are changing basically is the sign, the addition or subtraction sign between it. If it is addition, we change to subtraction, and if it is subtraction, we change to addition. So we might have a simple table, okay? We might have the sort, okay, and we might have the conjugate sort, just to explain further. We have the sort, we have the conjugate sort. Now, given let's say we have roots, like we have in our example here, root 2 plus root 3, root 2 plus root 3. Okay, what is going to be the conjugate sum? Technically, we are changing the sign at the center here. We are changing the sign at the center here. So it will give us root 2 minus root 3. Okay, and then if we are given 2 root 5 plus 3 root 3. Okay, so we are changing the sign at the center. So since this is positive, we change it to negative. Okay, so we have 2 root 5 minus 3 root 3. And going further, we have 4 root 2 minus 5 root 5. Since it is a negative sign, we're going to change to positive. So we have 4 root 2 plus 5 root 5. And finally, we can also have 1 plus root 2. Now, since this is positive at this center there, so we'll change to negative, right? So that will be 1 minus root 2. So with this idea of having conjugates of sorts, we can be able to perform operations such as multiplications and division of sorts. Alright, so and that will be the next video.